Let's do problem set 6-6. Starting with the exercises. So it looks like we're given two complex numbers, z1, z2, and then questions 1 and 2 are asking us for the product and also the quotient. So for the first one, let's start by rewriting this in exponential form. That's going to give us 2 times e to the I times pi over 4. That's by Euler's formula. And then z2 is going to be 6 times e to the power of I times pi over 12. Okay? So that tells us that z1, z2 is going to be equal to 12 times e to the power of I pi over 4 plus pi over 12. And if you add those two fractions, you are going to get pi over 3. So it's 12 times e to the I pi over 3. Okay? So, you could box that, or you could also get this into trigonometric form. You would have cosine pi over 3 plus I sine pi over 3. So that works too. You could also box that. Or you could calculate it all out. You do 12 times 1/2 plus root 3 over 2i equals 6 plus 6 root 3i. All right? And z1 divided by z2 is going to be 12 times e to the pi over 4 minus pi over 12. That's going to give us pi over 6. Okay, so graphing all of this. It's a little tricky because the radiuses are all over the place, aren't they? Oh dear, I've made a mistake here. All of those numbers are wrong because z1 divided by z2 should be 1/3, right? 2 over 6. So the magnitude here should be 1/3. This is 1/3, 1/3. So I should be getting root 3 over 6 plus 1/6 I. All right, and so if I plot everything, 2, 1 should be here. Sorry, z1 is here. Length 2, right? Then z2 is pi over 12, and it's radius 6. So that might be somewhere here. Then z1 times z2 is a pi over 3 with radius 12. So we might put that up here. then z1 divided by z2 might be like here or something. Okay, very hard to graph accurately, so maybe shouldn't have asked you that. Question B is quite similar. Let's first write it in exponential form. So the product, we're going to first multiply the constants in front, and then the angles will add. That'll give us 13 pi over 12. Okay. Then z1 divided by z2 will be 3/4 divided by 3 is 1/4. So that subtraction is negative 5/12. So in trigonometric form, both are acceptable. And then the graph is pretty straightforward. I'm not going to show it because I don't feel like it. Let's do the problems. So question 1, De Moivre's theorem. To calculate the first one, let's do root 2 over 2 plus root 2 over 2i to the power of 12. Okay, so the first step is to calculate the trigonometric form of this complex number. All right, so just write it out. So the magnitude of the complex number within the parentheses is 1, and so we don't need to factor out anything. And we just need to think now about what kind of angle on the unit circle corresponds to these numbers, right? And that is going to be cosine pi over 4 plus I sine pi over 4 to the power of 12. Okay, so now we just applied De Moivre's theorem. That means the exponent distributes to the angles, and we're going to be left with cosine 3 pi, because that's pi over 4 times 12. All right, and so cosine 3 pi is same as cosine pi, which is negative 1 plus 0i. So that's our answer. Next one. Here we're going to have to actually find the magnitude of what's in the middle. So here's the magnitude. So we'll square the real part, square the imaginary part. which will give us 3. Because that's 36 over 4, which is 9, and that's 3. Okay, so that means that 3/2 plus 3 root 3 over 2i to the power 4 is equal to 3 times 1/2 plus root 3 over 2i to the power of 4. Okay? We can simplify this as 3 to the 4th, and then write this in trigonometric form, which is cosine pi over 3 plus I sine pi over 3 to the power 4. And then we can apply de Moivre's theorem to the second term, which yields cosine 4 pi over 3 plus I sine 4 pi over 3. And now this is something we can calculate. Cosine 4 pi over 3 is -1/2, I think. And then sine 4 pi over 3 is negative root 3 over 2. So our final answer is negative 81 over 2 minus 81 root 3 over 2i. Part C. Okay, so this is quite similar. We can look at this and just know that the magnitude of the thing in the middle is 2. So we can factor that out. It's going to give us 2 to the power of 6. And then in trigonometric form, that is cosine pi over 6 plus sine pi over 6i to the power of 6. And then this is something we can use de Moivre's theorem for, which gives us cosine pi plus I sine pi, which is -1. So we get -64. Let's do question 2. These are not easy. So let's first remember the formula. Whenever we have z to the power of n equal some complex number in exponential form, it's going to have n solutions. And those n solutions are given by this formula here. Okay, and so we're just going to apply that to this question. Here we have z to the 6th equals 1. And so we're going to want to rewrite that in terms of exponential form. So 1 is just magnitude of 1, so that's r is 1, and the angle is 0, right? On the complex plane, the angle for 1 is 0, so we have e times to the power of I times 0. And so if you apply the formula, we just get r is 1, so it's 1 to the power of 1/6, which is just 1, obviously, times e to the power of I times theta over 6, which is 0, plus 2 pi k over 6. And if we simplify that, we're just going to get e to the power of I times pi k over 3. Okay, we're going to remember what is k, right? K is going to be 0, 1, all the way to 5. So it looks like I want it in standard form. Jeez, that's so annoying. Okay. I'm just checking what I have on the homework checks. See if it's really this annoying to do. Give me 1 second. Okay, is he cute? It's not bad. Okay. Interesting. Well, it's a good exercise, isn't it? So yes, we do need standard form. So let's do the first solution. When k equals 0, we have e to the power of I times 0, obviously. So that's just 1. For k equals 1, we're going to have e to the power of I pi over 3, which is cosine pi over 3 plus I sine pi over 3, which is 1/2 plus root 3 over 2I. For k equals 2, we have e to the I power times 2 pi over 3. Just going to stop talking. All right, so those are our 6 solutions. And when we plot them, it's easiest to plot based on the angles and not actually standard form. When we plot them, we have 1 is here, pi over 3 is here, 2 pi over 3 is here, 3 pi over 3, 4 pi over 3, and 5 pi over 3. So it forms a nice hexagon of complex numbers. All of these are length 1. Okay, 1 down. Z to the 4th equals -1. Okay, the first step is always, of course, to write this in exponential form. So we need to factor out the magnitude, which is 1. And then we're going to be left with, right, 0 minus 1i. Sorry, that's wrong. -1 plus 0i, which is e to the I pi. Right, the angle in this case is pi. If we drew it on the complex plane, we would be here. So that's the angle of pi. So that tells us that z equals e to the I pi over 4 plus 2 pi k over n, which is 4. For k equals 0, 1, 2, and 3. So our first solution, k equals 0, is going to be e to the I pi over 4, which is cosine pi over 4 plus I sine pi over 4. simplify these a little bit. All right, so those are our 4 solutions. When we plot them, we are going to get solutions at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, all with length 1. Third one. Z squared equals negative I. So let's first write this in terms of exponential form. It's going to be 1 times 0 minus 1i, right? So on the complex plane, that's right here. That forms an angle of 3 pi over 2, right? So this is e to the I 3 pi over 2. So that tells us that z equals e to the I 3 pi over 4, because that's this angle here, divided by 2, plus 2 pi k over 2, because n is 2 in this case, 4k equals 0 and 1. Right, there are only going to be 2 solutions here. And so the first solution is going to be e to the I times 3 pi over 4, which is negative root 2 over 2 plus root 2 over 2i. And the second solution is going to be e to the power of I times 7 pi over 4. So when we plot those, we're going to be here and here. 2 solutions. And you'll notice that, if we go from here to here, that's actually half the angle that's required to go all the way to I, negative I, right? So that's how those angles work. Last one. Z cubed equals 8. I feel like I did this in one of the periods. Anyways, 8 is equal to e times e to the I times 0, right? So that tells us that z is going to equal 8 to the 1/3, which is 2, times e to the power of I times 0 plus 2 pi k over n, which is 3. K equals 0. I'm going to have 2. For k equals 1, I'm going to get 2 times e to the power of I 2 pi over 3, which is 2 pi over 3. Where's that? Negative half plus root 3 over 2i. So negative 1 plus root 3i. K equals 2. All right, hopefully that's all correct and there are no typos.